Okay, so hello guys. So I am very happy to be the part of this wonderful conference. So today I'm going to speak about the uh, how to build the real-time data analytics with Redpanda and the kqslDB. Okay, so this is my introduction. I'm currently working on the MySQL and ClickHouse database administration. Currently working for ChistaDATA, and I love to learn the open source technologies, and I'm the active blogger, and I'm doing the technical videos for in YouTube as well. Okay, I'm from Tamil Nadu. So this is the agenda of the talk today. So first we will see the little overview about the real-time data platforms. Then we will see how the data streaming is happening from MySQL to kqslDB. And I have the use case, and we will see the demo session also. Okay. So this is the overview about the real-time data platform. So the real-time data platform infrastructure will allow you to process the real-time data analytics once the data becomes available. Okay, so but in the traditional way, we do the batch data process, which means there is a huge data. We will do the analytics using the ETL. That is also not very frequent. The organization may do weekly basics or monthly basics, or based on their requirement, they do the batch data process. But the real-time data platforms provide the real-time data analysis quicker. Okay, you can get the quicker insights about your customers and your data. So you can take the better decision, and you can take the quick decision in your business. It will be helpful to improve your business. Okay, and also you can customize your services based on the customer feedbacks and suggestions, and you can recommend some values to the customer. So these all things will happen when you have the real-time data platform build it in your organization. Okay, of course we have the challenges, because you are going to change your architecture. You are going to do some add-on in your architecture, so you need to do some investment, or maybe you need to choose the right stack which is suitable for your architecture. So those are the challenges in this implementing the real-time data platforms. So, and I would like to say the example also for this. I would call it as the Google Maps. So once you book the location, Google Map will automatically show you the real-time data. I mean, how much kilometers or meters you need to go your destination, and what is the current traffic over there. So those all informations will be updated in a second straight. So so that is the example for the real-time data platforms. Okay. So the next, let's see how the data streaming is happening from MySQL to kqslDB. Here, these are the main components I am using in this architecture. MySQL, it's the famous open source database, and DBCM Connect, which is used for the change data capture from the MySQL bin logs. And I'm using the Redpanda. That is some better compared than the Kafka, because we have the Zookeeper free and JVM free in the Redpanda, and Redpanda is also comparatively faster compared than the Kafka. And kqslDB, which is the streaming processing database for the, we can manage completely SQL. Okay, so I chosen the kqslDB, and this is the architecture. So I have the MySQL. Of course, to get the binlog process, we need some configurations. The MySQL, your MySQL should be configured with the row-based binlog format, and it would be more better if you have the full and server IDs. Those configurations are configured already. Okay, so I have the DBCM Connect, which will connect to MySQL, and it will get the data changes from the MySQL binlog, and it will send to the Redpanda. Okay, so Redpanda is the data streaming app, and it will send the data to the kqslDB. Then we will have the topics in the kqslDB. Then we need to trim the data, because by default the messages will have a lot of information. We don't need all those informations. We need to trim the message, and we need to trim what we need for the append, what we need. So we need to trim. We can use that in the kqslDB by using the sequence. Okay, and finally, the app will connect to the kqslDB and get the data. Okay, so what is the benefit of this implementation? So you can implement the streaming data platform, and this is completely Kafka compatible because we are using the Redpanda and kqslDB. kqslDB is built on the Kafka, and Redpanda is also the other version of Kafka, right, which is written by the C++. And Redpanda is faster than the Kafka and the hardware efficient. And when you are using the Redpanda, that is completely, as I told, Java virtual machine free and Zookeeper free. So that is simplified the architecture. We don't have that two components in your architecture. So, and the case when the kqslDB comes, that completely supports the SQL. You don't need the other coding languages like Java, Python. You can manage everything with the SQL. And kqslDB supports the push and pull queries. You can get the real-time data streaming, and you can also pull the data when needed. Okay, and this architecture is very easy to manage. Yeah. So the next thing is use case demo. So this is my simple use case. So I have the table order in my MySQL database, and I need to do the real-time analytics of the quantity of the orders from each customer. Okay, so this is my simple use case. Let's go to the demo. Okay. So I have prepared the Docker Compose file. So here I have all the components, Redpanda, and its configurations and the VCM Connect for the CDC purpose. And I have the MySQL, and I have the schema registry, and I have the kqslDB servers. So this is the Docker Compose file. So when I run this Docker Compose file, it will deploy all these components in the containers, and the configuration is also done. Okay, so let me show you one by one. So here I am running this Docker Compose -f ChistaDATA Redpanda. This is my YAML file name and up. Okay, so once I run this, you can see those containers are getting created here. And let me shift to next step. There is 1 second. Okay. Okay, so here you can find the status. Once the Docker Compose, that command is completed, you can find the status. So here you can see the schema registry and the kqslDB and the DBCM connector Redpanda and MySQL. Everything is running. Okay, everything is running here. So let me take you one by one. So here I logged in the container MySQL. Okay, just the MySQL container. So I logged in the inventory database. There I can find the tables, addresses, customers, geo, orders, and products, and product on band. So here in our use case, I need the orders table. So in the orders table, I have 4 records. Okay, so let me come to the next one. So this is the Redpanda container. I logged in here, and here you can see the topic list. Here, this is the topic from the MySQL. So whenever the change is happening in the MySQL, that change data will be stored in this topic. Okay, in the orders topic. And I also have the kqslDB installed. kqslDB is already configured with the Redpanda. It will get the topic directly from the Redpanda streaming. This is also already implemented through the Docker Compose files. Okay, so I logged in, and here I executed the command show topic. Here I can see the orders topic. Now let's see the example here. Okay, let me minimize the screen. Fine. So here I have splitted my terminal vertically. Okay, the first one is the MySQL, and the next one is the kqslDB. In the kqslDB, I am just giving the show topics command. It will display all the available topics here. And this is our use case, the inventory, that orders table, that is also in the streaming. Okay, so this is MySQL here. Select store from orders. I have 4 data here. Okay, so now how to as I told earlier, that by default, the streaming messages will have a lot of informations. Okay, we need to minimize, we need to trim that events messages, what we needed. Okay, for example, let me show you here. So I'm just printing this topic from beginning. So here you can see a lot of informations about the messages. Okay, so but here what we need exactly is the payload. This is the information mainly I need, because this contains the MySQL details, the before value, which is null because we did the insert, so which is null, and the after value here. Okay, for each column, order number and order date and purchaser and quantity, those things, quantity, purchaser, order date, that those informations are stored in the payload. The payload contains after and before values. Okay, so just from this lot of messages, I just need to trim this stream only to get the payloads first. Okay, so let me do that, how to get it. So I already prepared the queries for that to avoid the time consuming. So here are my queries. I'm going to just execute one by one. So first I am going to set the offset reset value to alias so that I can get this data from beginning. Okay, so I'm going to set this alias first in the kqslDB. Okay, so this is successfully changed. Now I'm going to create one stream. What it will do, it will get the before data. It will do process the payload first. It will do process the payload, and it will print the before data, and it will print the after data in the stream. Okay, so let me create this stream in the kqslDB. Okay, the stream got created. Now let's see what is in this stream. Select start from. Okay, so here you can see the before messages and the after messages. Okay, so now as I told, we have the insert, so the before message is null, but if you're doing the update or delete, then we will see some values. I will show the example later. Okay, so now I am processing this stream, this payload stored before after order stream, and I'm just going to extract the after values. I don't need the before values at the moment, but if needed, we can do that. But now I just need the after event. So I am executing this stream. It will process the payload, store before after orders, and it will just print the after values only. Let's see. Select start from after others. So you can see in the previous stream, we see that we see that before and after values, right? But with the latest stream, we can see only the after values. Here you can see the order number, which is the MySQL column, order date, purchaser, quantity, and the product ID. Okay, so now I'm going to create one more screen to separate these values in the columns. Okay, like MySQL. So this is the next stream I am going to create in the kqslDB. Okay, the stream got created. Let's see the values. So now you can see the column names here. Yeah, order number, order date, purchaser, quantity, and product ID. This is similar like MySQL. Okay, now what we have in this MySQL, we also have in this kqslDB. Okay, so this is something like we just stream the existing data from MySQL to kqslDB here. Now let's do some insert in the MySQL and see what is happening. Okay, so here I prepared this insert, I am doing this insert on the MySQL. So I have one more entry, which is 1005 for the order number. Now let's see in the kqslDB, the new event stream is happened or not. Okay. It's happened. Okay. So we can see the new ID 1005 in the kqslDB also. So this is the real time. So once the event happens available, once the data is available in your source database, that is also available for your analytics purpose. Okay, now we have some more things here. Let's do one update in the MySQL and see what happens. I'm doing this update with the MySQL. So what I'm going to do is I'm just updating the purchaser value 1002, where order number 1001. So I'm just updating this value 1001. Correct. I already have 1001 here. I'm just going to update it to 1002. So let me execute this query. I executed in MySQL. So now you see this purchaser value is changed to 1002. Previously it was 1001. Now let's see in the kqslDB. Okay. So now you can see one line here, 10001 for this order number, and I can see the latest value, which is purchaser 1002. But here the problem is we have other order number with 1001 also. So this is kind of duplication. Okay. So we have the duplicate values in the kqslDB here. So I need to overcome this also, right? So for that, so here I would like to share, we have the old value as well as we have the new value. Okay, that is the thing. So you can use this change log to capture, monitor your changes in your database also. That is the one thing I would like to share here. And to obtain the original values, we need to create one more table with the latest way offset, okay, function. So what it will do is, it will capture the latest changes for the columns and it will display the result. So let me try this. Okay, it is created. Let me query this table. So now you can see here that in previous value 1001 and 1001, we had the duplication, but after we implemented this function latest may offset over the columns after I am querying, I don't have any duplication and I have the updated value here. For example, in kqslDB 1001 has the purchaser 1002, and in the MySQL after the update I have the same value. So using this latest way offset function, you can get the original value, and without this function you can monitor your changes. Okay, you can capture your change log and you can monitor using this table columns with changes. And also I would like to show one more thing here, this function, okay, this string, because before value was null, right? After only we had, but we did one update in the MySQL. Now let's check this stream and what is there. So the first one we have before null, and the final after the update, you can see the previous value here and the after value here. So this is this is I just like to share. You can capture the before value and the after value. Okay, fine. So now let's come to our use case. So our use cases, our use cases here. I need the quantity of the orders from each customer. Okay, that is my use case. So here for that, I created one materialized view. So what it will do, it will select two columns, purchaser and the quantity, and it will do the sum of quantity from the total orders, and finally it will group by based on the purchaser to get that value. Okay, so let me create this. Okay, so let me query this view. This is actually materialized view, not a view. Okay, so now I can see the data for the purchaser 1002, total purchase number is 5, and for the purchaser 1003, total number purchases 1. You can verify here for 1003, we have 2 rows, 1003, which is 10 and 1, so totally 11. So we have 11, and this is for 1002, we have 3, 1 plus 2 plus 2, we have 5. Okay, so this is how we can do the real-time data analytics 6 using the kqslDB from the MySQL. Okay, fine. So at ChistaDATA, we are planning to write the series of blocks using the MySQLDB, Synchronite, and Redpanda. And kqslDB, I already explained. I also planning to write the block. And instead of kqslDB, we are also planning to write the block with the ClickHouse, because the ClickHouse have the support for the Kafka engine. So I think this is not a big deal to do that as well. So we are thinking of writing the blocks on that topic. And also we have the plan to compare both architecture and what is the result. Okay, so you can follow this link to see our blogs and stay tuned. Thank you. So yeah, thank you. So this is what I have now. Thank you very much, and enjoy the coming sessions. Thank you.
Thank you, Sri. There were 2 questions. The first question was on whether the sessions are recorded. And so, yes, every session is recorded, and we'll have the videos available over the next few days. So you'll be able to catch up on other sessions if you weren't able to watch, because we're running 2 tracks. And then if you just want to check in the Q&A, Sri, if you can see it, there might be a question there. And otherwise, then we would be good to go. I can read it.
Yeah, we can go, but I will answer this question later through the blog or something.
Okay, great.
Yeah.
Perfect. Well, then, thanks very much for the presentation, Sri.
Thank you.
And thanks everyone for attending. And OSA Con continues, so feel free to go to the next talks that you want to catch today. Thank you.
Yeah, thank you. Bye.
Bye.